Hello, my name is Sierra Sanchez, and this is my poster project presentation on the preparation of polyurethanes. So, a little bit of background into this. Polyurethanes are very versatile and useful materials that are synthesized through the addition polymerization of isocyanate terminated and alcohol terminated monomers. They undergo a lot of cross-linking, which produces a stiff and durable material that has many applications, such as electronics, medical devices, and more. The goal of this study is to find the optimal polymerization conditions for polyurethane synthesis. Optimal conditions will allow for a quick curing time that isn't so fast that the reaction could become out of control. Some things that affect curing time are catalyst concentration, the cross-linking agent used, and the density of cross-linking that happens within the polyurethane. So 3 different tests will be created to find the optimal catalyst concentration, cross-linking agent, and cross-linking density for polyurethane. All the tests will assess the viscosity, which is directly related to the curing of the polyurethane, and the viscosity will be assessed on a qualitative scale from 1 to 10. Here is a general reaction scheme for polyurethane using HMDI as the isocyanate containing monomer. We can see that when polyurethanes are synthesized, a carbonyl group will appear in the polymer structure, which is in neither of the reactants. For the first test, we determined that the optimal concentration of catalyst is 3 drops. From this graph, we see that when no drops of catalyst were added, the curing rate the curing of the polyurethane did not change over time. However, when 10 drops of catalyst were added, the polyurethane was almost solid within half an hour. This curing rate was decent. However, it happened so quickly that the reaction could be difficult to control. So 3 drops was determined to be ideal. Furthermore, 3 different cross-linking agents were tested. The cross-linking agents for these polyurethanes were the isocyanate terminated monomers, and those monomers can be seen here. 3 different samples were created, each with one of those different monomers, and it was found that the HMDI monomer created the most quickly cured polyurethane, becoming fully solid within 15 minutes. This means that a lot of cross-linking happened in the HMDI monomer as compared to the others. We can see that HMDI has the most flexible structure, meaning that the more flexible the structure of a cross-linking agent, the more likely it will be to cross-link. Desmador was better at cross-linking than IPDI, and both of these structures have very similar flexibilities, so it must mean that the functionality plays a role in the cross-linking as well. Desmador has more functionality than IPDI, and it has better cross-linking than IDPI, so that means that more functionality will also result in more cross-linking. Finally, the third test was to test the cross-linking densities effect on the curing rate. It was found that a 1-to-1 ratio of isocyanate terminated and alcohol terminated monomers resulted in optimal curing. Lower ratios of isocyanate to alcohol terminated monomers would result in little bits of unreacted monomer that would interrupt the structure of the polyurethane and decrease its viscosity. FTIR analysis of the samples from that final test we just discussed showed that upon the polyurethane synthesis, carbonyl peaks did appear in the FTIR spectrum, showing that we did successfully synthesize our desired polymer. Furthermore, a swell test on these same materials was taken, and it was found that non-polar solvent was better absorbed by the polymers due to the non-polar structure of the polyurethane, because these polyurethanes were relatively nonpolar. They attracted more of the nonpolar solvent inside of them and was able to hold on to that solvent longer due to the interactions. Also, it was found that the lower the cross-linking density in the polyurethane, the more solvent it would contain as well. This is because the lower the cross-linking density, the more porous or the less compact the polymer is. That means that more solvent will be able to absorb into the structure. In conclusion, the optimal curing conditions of polyurethane was determined to be 3 drops of catalyst. HDMI was determined to be the optimal cross-linking agent, and a 1-to-1 ratio of isocyanate terminated to alcohol terminated monomers was considered to be the ideal cross-linking density. Unless your desire for the polyurethane is to be an absorbent molecule, we would want it to be a 1-to-1 ratio. If we want it to be absorbent, we would need a lower ratio. To improve upon this study, we should test the viscosity by mechanical viscometers and not a qualitative scale. Finally, thank you to the Golden Gate Society of Coatings Technology, Dr. Zhang, and Dr. Leslie Hamachi.